Alright, so in this video we're going to apply concepts from forces and use springs and study basically how to figure out whatever we need to for a spring or use what we have for spring. So here's a very simple problem. Let us say that I have a spring that is that has a certain length, and our goal is to figure out the spring constant of the spring. Okay, so we're going to do something very simple. We're going to say that, okay, let us take this spring and let us exert a force on it, and we're going to do this by attaching a mass. Let's say I attach a 50-gram mass to the spring. 50-gram mass to the spring, and what we observe is, in doing so, that the spring has stretched by, let's say, 3 centimeters. Alright, and our goal is to find the spring constant. So the problem is very simple. What we understand is we have a block, so we add a 50-gram block to the spring. It causes the spring to stretch, as we already understand, and our goal is finding the spring constant K. Alright, so here's what is going on. What we also know, okay, let's also make this very clear, that at this stage, at the second stage, the block is in equilibrium. Now this is very important, because without this information we can't really proceed, or we don't really know how to proceed. So now that we know that the block is in equilibrium here, we understand something very simple that we could use. We could use all our concepts about forces, and equilibrium means what? Now think about it, and the answer would be equilibrium means nothing but the net force is equal to 0. So let's keep that in mind. And once we know that we're going to use we're going to use forces to solve the problem, first thing we do is we automatically draw a free body diagram. Now remember, it's a 50-gram mass, so we need to first make sure that we convert 50 grams to kilograms, and you go from grams to kilograms by dividing by 1,000. So this is actually 0.05 kg. Also, the 3 centimeters needs to be converted to meters, and from centimeters to meters you go by dividing by 100, and you have 0.03 meters. Alright, so we have all our components. Let's figure out the force of gravity, which is 0.05 times 9.8, and the other force that's acting on this is the spring force, which happens to be K times X. Notice that I have ignored the sign, and I've used the sign to figure out the direction of the spring force. And we see from this picture that since the spring has stretched, it wants to go back to its equilibrium position, and so the force of the spring is in the upward direction. So now that's how we utilize the sign. We don't really put the sign in the pictures. So once we get all this, what we know is that we can now, since the object is in equilibrium, all the forces cancel out, and so we know that K times X is equal to M times G, and so K is equal to M times G over X, and which happens to be 0.05 times 9.8 divided by 0.03. So which is nothing but 49 divided by 3. Just move the decimal places around a little bit just to be able to do a quick calculation, and this ends up being equal to 15.1 newtons per meter. Alright, what am I doing? 15.1, that's not right. 16.3 newtons per meter. So this is how we end up getting the spring constant for the spring. Alright, simple problem.